able to cut. We need other volunteers. So you guys, you can help us with cutting the videos in 7 minutes, 7 minutes. But that's fine for now. Let's first focus on the. Are you able to see my screen? Are you able to see my screen?
Yes, sir.
We are able to do it.
Okay. So now what we do is we're going to start looking at, let's say, some quadratic functions. Let's say you are given a function f of x given by, let's say, x squared minus 4x plus 3. So this is what usually you guys call quadratic function. So if you ask to evaluate, let's say, f of 2, what will you do if you ask to evaluate f of 2?
We substitute 2 where x
You
is.
substitute where there is x by 2. So let's say here is 2 to the power 4, then minus let's say 4 times 2, and then plus 3. So that's going to be 4 minus 8 plus 3, and then the answer is 7 minus 8, which is minus 1, right? So that's just a way to evaluate the function. So if you evaluate the function at a number, that is fine. So which means that you can literally also, instead of evaluating the function at a number, you can also evaluate it at a letter. So let's say when x is equal to let's say alpha, you can literally also evaluate f of alpha. Then f of alpha will just be alpha squared minus 4 alpha plus 3. And then with that in hand, you can also evaluate, let's say, at x equal to alpha plus h, you can also evaluate f of alpha plus h or f of a plus h. And then you just means you replace x by, let's say, alpha plus h squared minus 4 times alpha plus h, and then plus 3. Then you can break it down using the normal identity. The normal identities are when you have x plus y squared. So we are taught clearly in the high school that this can be actually evaluated using some identities, which is given by, let's say, alpha squared plus 2 alpha times h plus h squared, then minus 4 alpha minus 4h, and then plus 3. Now, so you can see that for a function, then you can also evaluate f of alpha plus beta plus h, and so on and so on and so forth, f of minus 3, f of 0, and so on and so forth. So this is basically a way of saying that when you have a function f of x, you can put anything inside the input as long as the input is inside your domain. So I haven't spoken to you about the domain yet, but this is as long as your function is within wherever that you put inside is within the domain, then you should be fine. Then minus 4 alpha plus 4 minus 4h plus 3 plus h squared. So then that is the function that we are evaluating at f of alpha plus h. Now with this in hand, then we can also evaluate the something else. You see, we have evaluated f of alpha, and then we have evaluated f of alpha plus h. Then we can also try to see that you can also evaluate f of alpha plus h minus f of alpha, right? So that is another way of seeing it. And then when you substitute, if you look at f of h plus alpha, it was alpha squared plus 2 alpha h, let's say plus h squared minus 4 alpha minus 4h, and then plus 3. Then f of alpha is become minus alpha squared. Let me go and check f of alpha minus alpha squared. So minus plus minus is become a plus, plus 4, let's say 4 alpha, and then minus 3, right? You can check if there are some issues, you will check. So this will just be equal to alpha squared minus alpha squared can cancel out. 3 minus 3 can also cancel out, right? So we have 3 minus 3 alpha squared minus alpha squared. Then let's look what else can cancel. 4 alpha and then minus 4 alpha can also cancel out. So we left with 2 alpha h plus h squared minus 4h. These are the one we left with. So, and if we now take f of alpha plus h minus f of alpha, then we divide it by h. Then we can see that if we divide by h, this will just be 2 alpha minus 4 plus h. Right? If we divide both sides by h, so it become another number which is known as 2 alpha minus 4 plus h. Then this is what usually you call first principle, and we're using it just to introduce the notion of derivative. Now, uh, do you guys have any issues in the simplification? I just divided by h both sides, right? Then I wrote just the simplified version. Is there any issue like that for that? Now, in addition to that, which means for a functions, when I started by writing f of x. And then I also evaluated f of 2, then f of alpha, then f of alpha plus h. Then I took f of alpha plus h minus f of alpha. Then I took f of alpha plus h minus f of alpha divided by h. So which means that the variable can actually even be anything. If you check alpha can take any other values, is the constant, you can fix it, or you can actually also vary it, take different values. The same for h. So in the same venom, if someone write a function, let's say by g of let's say g of a, let's say g of a given by let's say a squared plus 2a. So that's the function where a is in the domain. So basically that's the function. I can literally ask you to evaluate g of 2, g of 3, g of 4, g of 5. So for homework, I'm going to say evaluate g of 2, evaluate g of minus 2, evaluate g of minus 1, evaluate g of 0, and then so on and so forth. You can also evaluate g of 3 and g of 4. G of 3, evaluate g of 1, and then evaluate, and the last one is you evaluate g of 4, or g of minus 4 in fact. So you can see that is